And what do we mean by statistics, right? So remember, this is a very standard definition, okay. It is collecting. So do not think statistics is just all about what, presenting or giving the final output, okay. That is the poor way of thinking about statistics. Statistics starts all the way from collecting data, organizing them, presenting, analyzing and interpreting data to make effective decisions. It involves all aspects starting from collecting the data, okay. As I said, even when you collect, you have to be very careful about confounding effects, okay. Have you heard of a drug called Adderall? Adderall is a standard drug for today's problem of autism, ADHD, etc., especially hyperactive disorder, etc., okay. So this was not introduced now, this is a decade back. Still again there is a documentary in many again I think in Netflix, which talks about take your pills, okay. That is the documentary name, take your pills. So if you go look at it, even a small change in your milligrams can change lives, okay, even for a regular autistic kid, I mean who is abnormal or different. Even if you are prescribed, even if the person starts taking, you cannot reduce by 1 milligram or 2 milligram, suicidal effects, okay. And the kid says, I would have been very happy without this because I do not believe that I am what I am when I take this drug, I am zombied basically. But that is the treatment drug for, and there are of course arguments where it is nicely presented. So there are arguments where it was supportive, the kid could come across his school age crisis, etc., because they become ultimately focused. And this drug is pure meth, it is a pure methamphetamine taken via oral route instead of a injection, which is actually a drug addict, I mean they do it, but this is taken via orally methamphetamine, so that the person becomes focused. Now the issue is, what is the milligram level? Is the even doctor qualified to prescribe the quantity? The quantity plays a very, so the dosage, it is a drug which has a significant effect, it could help people, but the drug dosage is a $1 million question, right. A little high, the person gets zombied, and if you, after you realize that it is high and you bring him down, the person has suicidal thoughts for life. And this drug once taken has to be taken for life. Why? There is a serious withdrawal effects. Now these are the drugs which will have what we call it as, how do I manage, because is the risk outweigh the outcome or the outcome outweighs the risk? A very significant question which could change people's lives. How do I do that unless if I do a proper collection of data and then say, look, in this category this is the dosage or this is the range of dosage one should be taking. Evaluation, no single, if you collect all data and then say treat all of them equal, that is not going to work. Even under ADHD category, that is a broad spectrum, right. You cannot say it will work for everybody. Even people who work in Wall Street take this drug for focus, not knowing the effects. So should this drug be classified? How can one obtain a drug? So today this drug, so 10 years or 5 years back, probably everybody in the Wall Street had in their pockets an Adderall, 10 years back. It is called Adderall community, basically everybody had Adderall to focus on. Today after knowing it, after doing, no, it's actually usually retrospective, right. After knowing the results, people now call it as classified, and you cannot get a single drug unless without a lot of heavy monitoring. In the Europe this cannot be even gotten, it is very highly, each and every tablet is counted, but that is after so many years. What has the damage that is been done is already done, could have been avoided, could have been easily avoided if this stats were followed properly, right. So every drug, so you all know about this antiretroviral ARVs. Have you heard of ARV, antiretroviral drugs? That is another example where you never know whether what outweighs what. So ARVs comes up with its own high level of risk, meaning when a person, when a HIV immunodeficiency person, or for whatever reason a person takes ARV, they will have, many of them will have so many side effects. To manage the side effects itself is a course for them. Whether the risk outweighs the outcome of the disease or vice versa is a very important question. Again, stats play a role, right. So it involves right from collecting data, remember. So we are going to talk about how to collect, organize, present, analyze and interpret. Finally, how does it help in decision making? And humans are not natural statisticians. If you think about it, so to give you an idea, this is a very classic statement. The reason behind is why humans are not statisticians. If you look at stock markets, for example, it has been proven that a dead person earns more than a live person by investing. There is a very interesting study which says a dead person invests money in their name, and then because it is a dead, he cannot draw or get panic, right. So over a 30 years he invests, he becomes a millionaire, although he is dead, the name becomes a millionaire. The same thing, if a live person invests, at the end of 30 years he is close to where he was, or he is in debt. Reason, we are not statisticians, we do not look at data and we do not look at numbers, we go by intuitions, and many a times emotions take over. We have feelings, we think our gut feeling is always right, but not always, that is a catch, right. We are not good at picking out patterns from a sea of noisy data, right, although some of you may be, but not all, right. Picking up patterns is not a straightforward thing, okay. We also find it difficult to sort out the effects of multiple factors occurring simultaneously. So why do you want to do this? Why not just a human do this? Systematically we will not be able to eliminate multiple factors. Remember how many times in the history we have been doing retrospective decisions. That tells you that we are not good at capturing all the effects unless you do systematically. Even if you do systematically, things will evolve, but the effect may be little, okay. And finally, we are all subjected to biases, do not we, right. So in fact even within a class, if we come from a same region, we gel together, from a different region, slightly better, slightly worse, and depends, right. This is within a country. If you look at in a group where you are from different countries, naturally the biases shoot up to a great extent, right. So why statistics in our situation? Very simple, we are making decision in the presence of uncertainty. So one of the key things to remember when we learn about statistics or probability is, how is it different? So let me ask you a simple question. To calculate your payroll, how much you get paid every month, is there any uncertainty there? Is there any uncertainty? Day 31 or first of the month, you know what to expect, and that never changes, the rule remains, right. If you get a signature, if you have made your TA duty, you get a X amount, and that X amount is fixed based on some rules. Same applies to me. Clear? There is nothing uncertain about it. There is anything probabilistic about it? No. Give me an example where we want to talk about stats. I have not talked about probability. So let us say, where do I want to do stats? This is an example. Will you do stats here? Or will I get at the 31st of or 1st of every month? How much pay I will get? Is there any statistics involved? One number fixed. Force equal to mass into acceleration for all Newtonian purposes. Is there anything uncertainty there? No, right? Do you do statistics there? No. You just go by an equation and say, this is what my outcome is for this inputs. Where do we learn about, where do we start thinking about statistics? So what is my, what is the application area or domain where statistics will be involved? Not even domain, not a vertical, but what are the conditions or the main condition under which you have to worry about statistics? You have to bring in statistics, statistical analysis. When the outcomes of an experiment is uncertain. Whenever you deal with a random experiment, whenever you are doing a random experiment, what do I mean by a random experiment? What do I mean by a random experiment? What do I mean by a random experiment? Again, its outcomes are not certain. Even if you repeat under same conditions. Okay. So what do I mean by? So outcomes are uncertain even repeated under same conditions. Clear? So that is what it is. That is what makes the difference. Even if you repeat under same conditions, the outcomes are going to be different. Give me an example. Give me a simple real life example. Okay, clinical trials, okay. Biomedical, yes, that we discussed. What else? So that is one end. Stock markets. Stock market, what is repeating? Of course, today and tomorrow the same time the prices will not be same. If that is the case, that would have been wonderful. Okay. But that is not the case, right. So now you all know about cricket, right. So how do we decide a batting or a bowling? Is it a very important decision or not? Everybody knows cricket, right, because our country is a cricketing country. So everybody knows about it. How do we, is it important decision or not? Right. Is that there is a pitch report. Somebody talks about the pitch report, meaning how today the moisture, the ball, all blah blah blah, expert opinion. Weather report is there. So we know each game is actually a $1 million game, right, nothing less, right. Now choosing a batting versus bowling significantly influences the outcome, right, because if you know that it is going to rain in the evening, your decision is going to be drastically different depending upon the pitch, the dew conditions, etc. influences the outcomes significantly. How do you choose a batting or a bowling? It is a $1 million game and it is a very important decision. How do you choose it? Coin toss. Why? Why coin toss? Doesn't have any bias. Is that all? Is that all? Why a coin toss? Have you ever thought why a coin toss? Is that not bias? Is that the only question? Is that the only reason? So what does it mean? So what does it lead to? So he says even if you toss 10 times, I cannot say the 11th time is what? Will it be head or not? Tail, what will you say? What will be your answer? 10 times head is there, 11th time what will be the answer? Head or a tail? Huh? Suppose you want to bet your entire lifetime savings on it, what will you say? You will say I do not know, right? Wise person will say I do not know. Why? Because the outcomes are totally independent of the past. And remember what as a human we can model? So tomorrow, so men or humanity is good in modeling based on past, okay. But when past is not there and you cannot derive anything out of past, you fail to model, and that is a classic example of a tossing of a coin. When you fail to model, you call it as luck, right, and that is when we still toss a coin, because we fail to model that, because there is no past that will help me model the current. Now a random experiment, when we talk about, you have to be very clear, we are not talking about in biomedical, we are not talking about tossing of a coin, although that is the baseline saying this cannot be modeled, we are not talking about that. Imagine a drug you develop and say today it will work, tomorrow same time it may not work, same person, same time, same dose, it will not work. Are you, anybody will be willing to buy it? Is there any use? No. But then what are we then talking about? What kind of uncertainty are we talking about? What kind of uncertainty we are talking about? So we said it is not totally unpredictable, but then what is the example of a case where it is predictable but not to a great extent? Predictable but still there is randomness. You understand my question, everybody? We talked about random experiment, outcomes which are uncertain even under same conditions. Now I told you a simple example which is very useful, a tossing of a coin, which anyway cannot be predicted or useful for biomedical, because I said that cannot be your random experiment, because if the outcomes are independent, gone. I mean it has no relationship with past, that means today and tomorrow it will work, it will not work, nobody is going to buy it, it is of no use. Then what is the uncertainty we are talking about? What do you mean by the uncertainty? What is uncertain here then? Give me an example where it is there is a pattern but there is uncertainty. What is it? Huh?
In rainy season, for every day the rain may come or may not come.
Weather. You have a pattern, right? You have a pattern, and that is actually a lot of examples can be given. Weather, tomorrow will it have 45 degrees Celsius sunshine? No, not really. Or are you sure 100%? No, right? Cannot be. Earthquakes, tomorrow will earthquake happen? So most likely no. Why? Because in the past it is very rare, but question is it is rare, okay. There is uncertainty, whether you talk about weather, whether you talk about natural, same with stock markets, right. Today Nifty is maybe hovering around 20 plus thousand, will it go to 15 tomorrow? Most likely no, but most likely something happens tomorrow, yes, the event will happen, right. Now that is most likely no. Now we are not interested in Nifty hovering to 15,000, if it is at 20 and nobody will bet for 15,000, nobody will bet, it will be 0 rupees, will it come to 19,800 or will it go to 20,200? that is a tougher question, right. Will this drug work or not, that is actually an easier question to answer. What is difficult to question to answer? So suppose, will this drug be effective against certain disorder, yes or no? Yes or no is actually the easiest to answer, works, does not work. Now if you ask you how much percentage, to whom it will work, if it fails, to whom will not work, whether it will work on one gender, whether it will work on only on one gender, only on one age group, only for certain race, that becomes tougher questions. So the finer you quantify, try to quantify, the more difficult things will become, okay, because you are trying to predict. So what does actually statistics do? It tries you to give what? It tries you to give a way to predict things. It not only gives you, so when I say 95% of the time it works, what are you saying? Futuristically, what are you saying? You are saying tomorrow if you take this drug also it will work 95%. So you are actually using stats to predict, kind of tame the randomness. You know that randomness exists, but you want to tame the randomness and you want to make this uncertainty level higher or lower. You want to make it as much lower as possible, and that is where statistics is helping you take. You want to tame the randomness. So when you talk about statistics, remember you are talking about random experiment, outcomes of random experiment, and then trying to tame the randomness, so that giving insights, so that you make it, instead of a black box, as much as possible a certain, you can predict the outcome with certain certainty. You are trying to predict the outcome of an uncertain experiment with certain certainty. That is what we are heading to. Okay, that I will stop for today. So tomorrow we will talk about few use cases and then get into basics. Okay.